In this chapter, we're going to model the form for the roof. So what I'm going to do now is I want to turn this into more of a building shape by creating that sort of typical roof shape. And to do that, I'm going to branch off from this network, and we're going to create a roof template. So I like to block out the different areas of my network with nulls and net boxes. So for this bit, I'm just going to get my little null plugged in here, and we'll call this roof construct, so I know what it's doing. So after here I'm going to be constructing something to make the roof. Now what I want to do really is create a box of the similar shape and put it up into that sort of typical triangular shape. So very simply I'm going to create a bounds node. So what a bound node does, it creates a bounding box around our geometry, which is just sort of a box representation of the bounding box there. The advantage of using this node is I can adjust the upper and lower padding. Look, I can bring that up and down as I want. So yeah, we can bring that up or down. So I don't want to actually bring that down up, the bottom up. I want to bring the top down. Now what I'm going to do is just template my bricks here so I can get a rough idea of where that should go. Let's try maybe 1.2, something like that. Because I'm going to pull the center point up to about here to give us that sort of typical house-shaped arch. Now there's a few ways we can do this. We could split the polygon or whatever. What I'm actually going to do is use a box node. Now what's interesting about a box node, even though that generates a box, you'll notice there's an input. If I plug another geometry into the input, this box inherits that shape. It matches the bounding box. Now the reason I used a box this time is because I can choose the I can use the polygon mesh method, and I can change the divisions here to 3 by 2 by 2. And what that will do, it will give me that line up the center, which I can pull up in a minute to give me that sort of pointy bit that you see typically on a house there. Now, talking of procedurally, this geometry will never change. These points are always going to be these points. So I can actually make a manual selection in this case. Let's create another group. So again, we'll use a group to do this. I want to set this to points, and I'm going to call this center, because these will be the center points. And we can just select them here in the base group. I can click on this little arrow at the side, and look, we can select the points manually with a shift. If I hit enter, it lists the point numbers here, and they've been selected. Now this isn't really procedural because I had to manually put those numbers in. If this was to change topology, then this group would no longer work. But in this case, this model is never going to change topology, so that's always going to be those points. So I'm okay to do that. A bit later on I'll show you a method that if it does change, how we can always guarantee this, the middle points being selected. But for now I'm just going to do it by hand. So like we did before, we're going to add a transform node. And in our transform node, we can choose our group, center group. And if I hit enter, we can lift that up and down. And we can kind of make that pointy shape that we want to see on our house there. Now, yep. So if it bothers you that the pivot's not at the top there, we can actually offset the pivot. If we go to the pivot transform here, we can move the pivot around and offset it. And remember we used that expression, the variable $y_min for the minimum bounding box. Well, we can use the same one here for $y_max for the maximum, because we want it to go to the top of the bounding box. So we can do $y_max, and you'll see the pivot now always stays at the top of the bounding box. So that's if you want to keep your handle in a more easier place. So let's set that to maybe 1 unit, and we get our sort of peaked roof here. This will be our template. Now I don't want these lines up the edges because they'll cause a bit of a problem, because shortly I'm going to actually Boolean, using Houdini's fantastic Boolean tool, to cut away the bricks that we don't need. And this line across the center will cause issues for that. So what I'm going to do is create a dissolve node to basically dissolve or delete that edge. So we can pop this in here. You see it's dissolved everything. But again, if I click on this little selector at the end here, this little corner, Now we do want to change this on by right clicking here to edges, and then I can shift select the edges here. We can select the edge loop, but I'll just do it manually. Once you're happy with your edge selection, you can hit enter, and you'll see the edges are listed up here, and it's removed them for us. That didn't actually work that time. Let's try that again. So 1, 2, 3, 4. We'll hit enter, and there you go, it worked that time. So it's dissolved all the edges for us, and that's given us sort of this block shape, which would be good for our boolean. I didn't mean to do that top one actually. Let me undo that. Let me just, which one was that? Was that this edge? Nope. Let's just get rid of all of those and do that again. So it's just this one we want to remove, this one and this one. Obviously we need the top one still there. Let's hit enter. There we go, that's better. That's the shape I want. So let's just tidy that up, and I'm going to create a null at the end of this. And we'll call this roof cutter out. So that's going to actually we should call it roof construct out, shouldn't we? Should be consistent. Roof construct out. So we know that that's what that's doing. So I said I like to use netboxes to keep my networks neat. So I'm just going to select this lot and click on this little icon here. This will create the network box, and then we can just rename this to roof construct. I already copied that name, and you can even tap C for your color palette, select that and give it a funky color if you want, just to keep things nice and easy. So how are we going to do that? What are we going to do with this? Well, I want to cut out the shape of the bricks, and to do that I'm going to use a boolean. So let's hit tab and type boolean, and what we'll do is we'll plug our bricks in first, because it's the bricks we want to keep, and then we'll plug in our roof cutter to the second input, and we'll change this to intersection, and that just gives us the area that was intersected between the two shapes and effectively cut our roof section off for us. And this is nicely procedural, because again, if we grab that transform, we can lift this top up and down and change sort of where we're cutting the bricks. And again, we can go back to our resample node right at the beginning, and we can change the number of bricks, and that slope will match what we're doing, because it's all built dependent from the same shapes. Now there's a slight issue with using the boolean like this, although it seems like the right thing to do. If we create an exploded view node, this will show us what polygons are connected to each other. And in fact, what you need to do is just add an assemble node before that to help that to work, and it's still not working. Interesting. Yep, it's because it's not created great topology for us. It's actually not the best way to do this. You don't really want to add the boolean straight in. What we really want to do is to basically do a boolean on each brick individually. That way we'll get a more robust geometry, because this way you can see by the way it's shading funny here, we're getting some funny some not nicely drawn topology, not nicely built topology. So as I mentioned, we want to loop through each brick individually. Now that's fairly easy to do in Houdini. We can hit tab and type 4, and we can use this for each connected piece. So if you think about it, each block is its own connected piece there. So let's plug that in. This is very easy to use. We plug our thing in here, and if we turn on the bottom node, you'll see at the moment we've got all our bricks here. Now this is actually looping through each brick individually. We can turn on single pass, and we'll see sort of the first brick, and if we slide this we'll see each brick individually through the loop. If we turn that off, it does them all simultaneously. All we need to do is plug our boolean into that. So by holding Y and left clicking and slide across the noodle here, I can disconnect that, and then I can just simply connect in the boolean like this, and it takes a second for it to loop through all of them. Let's plug that in like this, and then what you'll see is now we're getting nice topology there. So this time if I add an assemble node afterwards, and then I add a exploded view, you'll see it properly now explodes out the bricks, and we can see that we've now got a bunch of individual brick shards. This will be good for when we come to do our simulation later. So it's important to do that. If you don't do it that way, let me just remind you again. Let me just make a copy of the Boolean. So with the other way, we get this. If I plug that in, you'll see it doesn't separate them because they're not all separate pieces of geometry. It's messed up the topology for us. So we really want to loop through the individual bricks like this. Now this is a little slow. This can get a little slow if we get a lot of bricks in there. Let me show you. If I go to my transform node now and drag this up and down, you'll see it's a bit laggy. So we can actually optimize these for loops. Now before you do that, let me just show you. What we're going to do is compile this for loop, and it makes these guys run very, very much quicker. Depends on the speed of your system, and it's multi-threaded, which is a wonderful thing. If you actually select the bottom node, you can see here it says multi-threaded when compiled. If you turn that on, that doesn't actually affect anything yet. We need to compile this, and to do that we've got to put this into a compiled block. And before we do that, we have to tidy up all these loose ends sticking out of this brown bubble. This brown bubble represents the loop, and we need to compile this loop and everything within it. We can see that this connection goes through a brown input, but this one doesn't, and that will break our compiling. So we need to make sure that all the inputs into one of these brown bubbles has one of these brown nodes, and they're easy to make. You can just make a copy of this node by holding down Alt and left dragging it, and in the copy here you can change its function at the top. Just set it to fetch input. So it does nothing but goes over the spare inputs here. So let's drag this over that noggin, over that line, and look, we can see now that that line comes in to the bubble correctly. Now you need to do this, make sure all these loose ends are tied up like this if you want to compile this. So how do you compile it? Well, you have to encapsulate it into another bubble again. So let's hit tab and type compile, and we'll see we'll get a compiled block. If you bring that in, you'll see it's like a yellow version of the loop. And again, we need to encapsulate this entirely. So if you think about it, we've got two inputs again, and we've only got one of these nodes. So again, let's make a copy of that. So we've got 2 for 2. And the same way we plugged in the for each, we'll take the first one over this first input, take the next one over the next input, and the last one outside the third one. So what you can see is we have our yellow bubble, or amoeba, or whatever you want to call it, encapsulating the brown one perfectly, and all the lines are coming in through these inputs. Now this will work for us. If we turn on the bottom node, don't forget on this for each to make sure multi-threaded is turned on, otherwise there's no advantage. So let's click back to this bottom node, and let's try selecting our transform and moving it again. And you'll see the interaction now is a lot faster. In fact, it's very, very reactive. So this is a great way to speed up your performance if you're using for loops, especially if you're doing things like this. You can encapsulate them into compile blocks. But remember, all of these inputs need to be taken care of. So if you set up your loop first, just make copies of this guy and set them to fetch input and plug them into all the spare inputs. And then you can make your compile block around the outside following the same idea, putting these yellow inputs on all the noodles coming in. Once your two bubbles are properly encapsulated, then it should work. There is one other caveat. If with your cursor over this display, tap D or click on the eyeball here and click on badges. If we scroll down, there's a where are they? We can click on this context-specific badges. And the badge I'm after is this non-compilable SOP badge. We'll see that's actually set to normal. So some nodes are non-compilable, meaning you can't use them in this loop here. Let's see if I can find one. Let's have a look at a paint node. Yep. So if you look at the paint node, you'll see that has the icon. So you can't use an attribute paint node inside one of these constructs. So some nodes can't be compiled, but most of them can, which is a great thing. So now we've managed to cut our shape of our roof there. Excellent. So what I'm going to do now is create a procedural template for doors and windows in a similar manner, and we're going to boolean those out from these main bricks.